Hey everyone. Look, we are living through this just incredible AI revolution, right? New tools, new breakthroughs, it seems like they're popping up every single day. It can feel like a lot to keep up with, I know. But the story of how we actually got here, well, that's one of the most exciting stories in modern science. So let's dive in and pull back the curtain on the one big idea that truly changed everything.
So, you gotta ask, what was it? What was that big idea? I mean, was it just having more data? Or, faster computers? And look, don't get me wrong, those things were absolutely crucial. But there was this one single, almost elegant concept that was like the key that unlocked the massive potential we're all seeing today. And that is the journey we're gonna go on right now.
Okay, so to really get a handle on this revolution, we've got to go back, way back to the beginning. See, before an AI can write you an email or dream up some incredible image, it first has to, well, it has to learn. But how on earth do you teach a machine to think? Well, it turns out the answer starts by looking at the most powerful computer we know of, the one right inside our own heads.
Yep, the human brain. That's really the core idea here. For, more than 70 years now, researchers have been trying to build what they call artificial neural networks. And the whole point is to mimic the way our own brains work. You know, that huge, messy web of interconnected neurons all firing together. The big goal? To create a system that could actually learn from experience, pretty much just like you and I do.
And this is the basic building block of it all, the artificial neuron. It's got a fancy name, the perceptron, but the idea behind it is actually surprisingly simple. So here's how it works. First, it takes in a bunch of different pieces of information. We call those inputs. Then for each input, it multiplies it by a weight. Now, a weight is really just a number that says, hey, how important is this piece of info? Finally, it just adds them all up. And if that total number crosses a certain line, bang, it fires. It produces an output. You can really just think of it as one tiny little decision maker.
So you have this little decision maker, but how does it learn which inputs are important, right? How does it figure out how to set all those weights correctly? Well, one of the most popular ways is basically by giving it an instruction manual. This whole process is called supervised learning. And it's kind of like this. Imagine you're teaching a machine to spot different animals in photos. You'd show it thousands, maybe millions of pictures, and every single one would have a label on it. This is a cat, that's a koala, here's a turtle. That whole labeled data set, that's the answer key. So the network takes a guess, then it checks the answer key. If it got it wrong, it just nudges its internal weights a little bit, trying to do better the next time. And it does this over and over and over again, millions of times, until it gets incredibly good at it.
Okay, now here's where the deep part of deep learning comes into play. You don't just use one of these neurons, of course. You stack them. You put them in layers, lots and lots of layers. So the first layer, it might learn to recognize really simple stuff, like edges and colors. The next layer up takes those edges and colors and combines them to see shapes. And the layer after that, it combines the shapes to see things like eyes and noses. By stacking up all these layers, these deep networks can learn to recognize incredibly abstract and complex patterns in the data.
Now, this whole approach was super powerful, for sure. But for one of the most important jobs we wanted AI to do, understanding human language, it had a major problem. It was just slow. It was clunky. Progress was happening, yeah, but it was crawling along. There was this huge bottleneck that was holding back a real revolution. That is, until 2017, when one single research paper came along and changed absolutely everything. Okay, so here's the critical thing you need to understand. The early models for language, these things called recurrent neural networks, or RNNs, they read sentences pretty much the same way we do, one word at a time from left to right. And I mean, that sounds logical, doesn't it? But it created this massive bottleneck. Think about it. To understand the meaning of the last word in a really long paragraph, the model had to somehow keep every single word that came before it in its memory. That process is just incredibly slow and super expensive computationally speaking. It turned processing huge amounts of text into a total slog. And it was basically impossible to run efficiently on modern hardware like the GPUs we have today.
So let's just put this in perspective. Look at the history here. You've got the perceptron all the way back in the 50s. Then in the 70s, a big breakthrough in how networks learn from their mistakes. Then, in 97, we get a better memory system for those RNNs we were just talking about. It was this long, slow road of steady, incremental progress. And then, bam, 2017, a huge leap forward, the transformer.
And this was the paper. Attention is all you need. It was published by 8 researchers from Google. And yeah, the title is a fun little nod to the Beatles, which is cool. But what was inside? It was just breathtakingly revolutionary. It introduced this brand new architecture called the transformer. And the way it just completely shattered that one word at a time bottleneck, honestly, it was nothing short of brilliant.
And this chart just lays out the difference perfectly. So instead of reading one word at a time, the transformer could look at every single word in a sentence, or even a whole document, all at the same time. It used this clever mechanism called self-attention to figure out how every word relates to every other word all at once. And what did that mean? No more bottleneck. Gone. It could process information in parallel, which made it absolutely perfect for modern GPUs and let it scale up to sizes that were just unimaginable before.
And listen, this wasn't just some small, nerdy theoretical improvement. No way. This one single idea, processing everything in parallel with this attention mechanism, it unleashed a tidal wave of innovation. It is the direct cause of the AI boom that we are all living through right now. So let's take a look at how this one elegant idea powers the tools that so many of us are using every single day.
I mean, think about it. Almost every single major AI breakthrough you've heard of in the last few years is built on top of this transformer architecture. Google's BERT model, the thing that makes Google search so good, that's a transformer. OpenAI's entire GPT series, including, of course, ChatGPT, all transformers. Even those incredible image generators like DALL-E and Stable Diffusion, yep, they all come from this one foundational paper.
And if you need any more proof of just how colossal the impact was, just look at this number. This single paper has been cited by other academic researchers over 173,000 times. That is just staggering. It's not a paper anymore. It's the very bedrock of modern AI, a true landmark in the history of science, period.
So, okay, this incredible tech is obviously not just stuck in some research lab anymore. It's here, it's in our hands, and it's fundamentally changing how we work. The whole conversation is now shifting away from thinking of AI as just a tool, like a hammer or a spreadsheet, to something much more profound. AI as a partner, as a collaborator.
And this quote from Microsoft's Aparna Chennapragada really nails the new way of thinking. It's not about replacing us. It's about amplifying us, giving us superpowers to tackle bigger, more creative challenges than we ever could before. So what we're seeing now is the rise of these AI agents that really do act like digital coworkers. I mean, just imagine a tiny team trying to launch a huge global marketing campaign. A few years ago, that would be impossible. But now, they could do it in a matter of days because their AI teammate is handling all the data analysis, generating the content, doing all the personalization, while the human members get to focus on the big picture, on the strategy and the core creative ideas.
But look, this new kind of partnership, it definitely comes with new responsibilities. I mean, as we start giving these AI agents more access to our data and more autonomy to act on their own, we have to start thinking about their security with the same seriousness we'd give a human employee, right? Trust is absolutely everything here, and that means we have to build in the safeguards right from the start. And the potential for this kind of human amplification is, well, it's just mind-blowing. Take a look at this. It's from a study on solving really complex medical cases. A Microsoft AI system, it achieved over 85% accuracy. Now, experienced physicians working on their own, they came in at 20%. That gap is just incredible. And again, the point here isn't to replace doctors, it's about giving them a powerful partner that can help close these critical gaps in care and ultimately lead to way better outcomes for patients.
Which brings us to the final and maybe the most important question of all. As these AI systems get more and more capable, as they evolve from just being tools into being true partners, we have to decide what our role is. What's the one human skill we should never, ever delegate? What is that core of human creativity, of judgment, of empathy that we need to make sure always stays right at the center of everything we do? That is the conversation we all need to start having. Thanks for joining me.